For number 43, first I ask for a graph using a graphing utility. There she is. Next, they ask for an interval of theta values, which would cause a particle to traverse this entire curve exactly once. Suppose we started at the origin. At this point, the pole, r is 0. Start moving along the curve. Maybe go in this direction. By the time we get to the pole again, r is 0 a second time. Keep moving. We're wondering how long it takes in terms of theta to traverse this entire path. By the time we have r equals 0 a third time, we've traversed the entire path. So let's start at the pole. R is equal to 0 at the pole when our r expression is equal to 0, which is when cosine of theta is 2/5. Think of the unit circle, and the cosine ratio is the x-coordinate. The x-coordinate is 0.4. We know that the x-coordinate is 0.5 at pi over 3, so it'll be a little bit past pi over 3. And there's actually two places where the cosine ratio is going to be 2/5. Your calculator is only going to give you this one, but if you keep rotating, we'll get another one over here. And if you keep rotating past that, we'll come back here 2 pi radians after the first time. But remember, we're trying to find 3 values of r equals 0. So once we have the first one, as we traverse, we'll hit r equals 0 a second time and a third time. And that will give us the answer to an example of an interval of theta values, which causes us to traverse the path an entire time. Well, we don't really even have to deal with the inverse cosine to find theta, because we know that this right here, inverse cosine of 2/5, is the angle measure where r is 0, represented in quadrant 1. And if we keep rotating, the second time r is 0 will be in quadrant 4, and the third time r is 0 is exactly 1 revolution past the first time. And as we talked about, when r is 0 once, and then twice, and then 3 times, we've traversed the path once. So if we start right here at inverse cosine of 2/5, we're at r equals 0 the first time, the second time, the third time. We've traversed the path 1 complete time after 1 full revolution. So for any interval that spans 2 pi radians, we will do the path exactly once. So let's say from 0 to 2 pi. We could say from negative pi to positive pi, or 1 pi to 3 pi. As long as the interval is 2 pi radians, we will traverse this entire curve exactly once. Change the boundaries a little bit, you'll start somewhere else, but if you go 2 pi radians, you always do exactly 1 lap.